Welcome to another episode of ResearchPod.
Today we're looking at a study from the NETCARE project. Researchers flew a specialized aircraft through the exhaust trail of a Canadian Coast Guard icebreaker called the Amundsen to measure exactly what it releases into the Arctic air, and whether that changes when the ship is actively crushing through sea ice versus sailing through open water.
So the central question is, does the physical effort of breaking ice make a ship more polluting?
That's the core of it. But the study also looks at what happens to that exhaust once it leaves the ship. In the Arctic, the air behaves differently than it does in warmer places, and that changes how pollution spreads, sometimes in ways that make it more persistent than we'd expect.
And the timing matters here. As Arctic ice melts, more ships are heading up there. If we don't understand how their engines behave when they're actually fighting through ice, we can't accurately predict the environmental impact.
Exactly. Most of what we know about ship pollution comes from large cargo vessels in the open ocean. But an icebreaker is a different kind of machine. It has to push against massive physical resistance, which puts a unique strain on the engine, and that strain shows up in the exhaust.
So how do you even measure the smoke from a ship moving through a frozen wilderness?
They used a specialized aircraft that could fly directly through the trail of exhaust behind the ship. Think of a ship's exhaust as a long, invisible ribbon stretching out for miles in the sky. To collect a sample, the pilots steer the plane right into that ribbon to catch the gases and particles. Scientists call this a Plume Intercept.
And what are they actually looking for when they do that?
They're measuring what's called an emission factor. Think of it like a recipe ratio. For every kilogram of fuel the ship burns, how many grams of a specific pollutant come out? They measured things like nitrogen oxides, gases that can cause breathing problems, and tiny particles of soot.
So they're building a kind of chemical fingerprint for the ship. Does that fingerprint change when it hits the ice?
It does, quite noticeably. When the Amundsen started breaking ice, the amount of nitrogen oxides came close to doubling compared to when it was sailing through open water. The reason comes down to how the engine works. When it has to push against the resistance of thick ice, it runs harder and hotter. And it's that higher temperature inside the combustion chamber that drives the chemistry. Hotter burning produces more of those nitrogen oxide gases. More effort, more heat, more pollution.
So the harder the engine works, the more of these gases it pumps out. But you mentioned the Arctic air itself plays a role in what happens next.
This is where the behavior of the air near the surface becomes important. Imagine the air close to the ground as a room. In most places, the sun warms the ground, which creates rising air currents that act like a giant fan, mixing everything up and diluting pollutants. But in the Arctic, the air sits in very stable, still layers and doesn't mix vertically in the same way.
Like a room with no ventilation, where smoke from a candle just hangs in a thick cloud instead of dispersing?
Precisely. Because there's very little of that churning, mixing action, the ship's exhaust stays concentrated for much longer. The researchers found that the plume expanded far more slowly than what we see in warmer climates. The pollution stays dense and potent rather than thinning out.
So it's a double effect. The ship produces more pollutants while breaking ice, and then the Arctic air holds those pollutants together instead of dispersing them.
That's the central finding. The study suggests that if we apply the same calculations to the Arctic that we use elsewhere, we'll significantly underestimate how much pollution is actually lingering in these sensitive environments.
And if the exhaust doesn't clear, it must eventually settle on the ice itself.
That's the concern. One of the things they specifically measured was soot, very fine, dark carbon particles. When that dark material lands on white ice, it absorbs sunlight rather than reflecting it, which can accelerate melting. By measuring these plumes directly, researchers can start building more accurate pictures of where that soot is actually going and how much of it is accumulating.
Was this the first time anyone had flown a plane through an icebreaker's exhaust while it was actively crushing ice?
Correct. Previous studies were done when ships were idling or moving through open water. This gives us the first direct measurements of what happens during the hardest phase of Arctic navigation, and that matters because it's precisely the phase that produces the most pollution. It's a meaningful step toward building the kind of accurate data that could inform better rules for how ships operate in the North.
And on that note, thanks for listening to ResearchPod.